Okay, welcome to Level 1 Science Online with Henny van Vieren. Okay guys, so here we have question 2 of 2020. Below is a pedigree chart for a family with a genetic disorder, Polycystic Kidney disease. And you can see poly means a lot, and you can see all of these cysts on the kidneys. It looks like a terrible, terrible disease. So, it's a genetic disorder, so it means it's passed on through the genes. Now, when you are affected, you are colored in black. When you are unaffected, it is not colored. So, consequently, in this case, the mom was affected with polycystic kidney disease. The dad was not. Now, let's read a little bit further. Polycystic kidney disease is by a dominant allele, and the unaffected is recessive. Complete the Punnett Square for the cross between individual 1, which is homozygous recessive. Now remember, if you are recessive and you display the recessive trait, and in this case it will be healthy, you have to be little h, is it h? Sorry. Little d. Just take that away. So, little d. Okay. Now, complete the Punnett Square for the cross between individual 1, homozygous recessive, and individual 2, which is heterozygous for polycystic kidney disease. Heterozygous. So, hetero means different. So, it's going to be big D, little d. So, let's go and complete that Punnett Square. So here's our Punnett Square. Now when they give you a Punnett Square with circles like this, don't be confused. They want you to put, if this is individual 1 over here, they want you to put, why do I keep on going back to the H's from Huntington's disease? Sorry. Little d, and then over here is going to be individual 2, and that's going to be big D, little d, and big D, and little d, and little d, and little d. And that's simply to show you the gametes, in this case it's the sperm, that the dad can produce, and the gametes, and in this case it's the egg, that the mom can produce. Okay, so when you look at that, she will give a capital D to one of her eggs and a little d to the other. So we take this D, and because it's from the mom, let's give it a different color, so make that a D and a D, and then we bring down the dad. He can only give little d's. Okay, and then bring the mom's little d across. So in their offspring, they have a 1-to-1 ratio chance of having somebody that has polycystic to normal ratio. So 1-to-1 ratio, or in other words, a 50% chance of producing offspring with the disease and 50% chance of producing offspring without the disease. Now, list the genotypes of the following two individuals, individual 3 and 4. So let's go back to our pedigree chart. I like this. Now, individual 4 is not affected, so she is displaying the recessive trait, which means she has to be little d. Now, you can see here that all 3 their kids of these two have got the disease, and the dad can only give a little d, and the dad can only give a little d, and the dad can only give a little d, whereas the mom had to have for all of them given her big D and not her little d, because she had a 50-50 chance of having a child that is affected and a child that is not affected. Now, if we then look at the rest of them, so number 7 displays the recessive trait, which means little d. So that meant that this dad who has the disease had to have given his little d down here, and the mom who's not affected at all, she can only give little d's. So she had to give hers. She had to give her little d there, and she had to give her little d there. Whereas this guy obviously gave a capital there and a capital there. So just like that, we have figured out this whole what do we call this, pedigree chart. Okay, so list the genotypes of individuals 3 and individual 4. We did that up there. Let me just get them again. So 3 was heterozygous and 4 is homozygous. So 4 is homozygous recessive and 3 is heterozygous. Beautiful. Now, next part of the question. Explain how you worked out the genotype for individual 3. You should support your answer by using evidence from both parents and children of individual 3. So how did we figure it out? We said that individual 3's dad, so number 1, is homozygous recessive and consequently can only give a little d. However, the mom, she is heterozygous. Now you obviously have to write the words when we do this, okay? And she can give both. Now, number 3 then, he displays the disease. So he has to have one dominant gene, and the dad could not give a dominant gene, so it has to be a heterozygote. But to further support that, if you look at his offspring, his own child, and individual 7 over there is homozygous recessive. So individual 7 proves to us that number 3 has to be heterozygous, because number 7 is homozygous recessive. He had to get a recessive gene from both parents. Therefore, number 3 has to be heterozygous, because number 4, remember, is the mom. Number 4 is homozygous recessive, meaning she is unaffected, which is little d, and she can only give a little d. Okay. And then it says one of the family members has kidney failure as a result of an infection. Okay, now that's quite different. Now we have kidney failure due to an infection. Can you see an infection? It's got nothing to do with your genetics. Okay? Can you pass on an infection to your children through your genes? And the answer is no. An infection is affecting you now, and just because I have, I don't know, if I get COVID and I have a baby, if I produce more children, they will not have COVID, because it is a environmental condition. Do you understand the difference? So discuss if this type of kidney failure can be inherited by any future children they have. No. Okay, so absolutely no. The infection is caused by an environmental factor. And not a mutation that will be passed on through the gametes. Sorry, spelling over there. Okay, so that's high level the answer. Let's look at the model answer. So here's question 2. So they've given us the Punnett Square there, and you can see it is the 50% or a 1-to-1 ratio. And if you had only one line in the Punnett Square correct, you got an A. Isn't that crazy? So literally, you only needed that or that, which I find amazing. Anyways, so any correct genotype can be taken from the Punnett Square. So so basically for A, you had to have either DD, big D, little d, or little d, little d. Amazing. Okay, then question 3. Question C. Remember they said, why do you know that 3 is heterozygous? So the parents could either pass down a capital D or a little d, because it has the genotype of heterozygous. Parent 2 could either pass down that. They tell us that in the question. Parent 2 must have passed down a capital D for the individual 3 to be affected by polycystic kidney disease. Parent 1 must have passed down a little d recessive allele to 3 because it has the genotype of homozygous recessive and only has a little d to give. When we then look at number 3's children, the offspring of the cross 3 and 4 are both affected and unaffected. This proves that 3 has the genotype big D little d and not big D because offspring number 7 is unaffected and homozygous recessive and thus must have inherited a little d from both parents 3 and 4. This proves 3 must have a little d to pass down, otherwise we won't see that, to number 7, and it must have a big D because the other child is affected. Okay, thus it proves number 3 is big D, little d. So if you said that number 3 had a D allele because it's affected by polycystic disease, then you get an A. Parents 1 and 2 pass down a dominant and recessive allele to 3. Yep. We said that, and offspring 7 inherited a recessive allele passed down from 3 and 4. Then, for merit, you comprehensively explain, and there's 2 opportunities for merit here. You fully explain why 3 has inherited the genotype big D little d due to the parent 1 passing down the recessive allele and parent 2 passing down the dominant allele. Okay, so we talk there about his number 3's parents. And then over here, fully explain why number 3 has the genotype heterozygous due to passing on the recessive allele to, so then we're talking about his children. Okay, now when we go from his kids and then we put the 2 together, then you can get your E. Okay, so if you had both of these, you should get an E. Comprehensively explain the genotype using 3, inheritance from his parents and passing on to his children. So that's an easy E to get there. Now the last question then was why infection is an environmental effect and not a genetic effect. So the kidney failure was due to an infection. Kidney failure was caused by the environment and not genetics. Only genetic characteristics can be inherited and not those acquired as a result of the environment. We said that. Reproductive cells, the gametes, can only pass on the genetic characteristic, and thus kidney failure caused by an infection will not go to the offspring. We said all of that. So if you just said that kidney disease is this kidney failure, but because of the infection, it was either environmental or infection, then you get an A. States only genetic traits or information in gametes can be passed on, it was another A. And then somatic body cells change and cannot be passed on. So your somatic body cells. Now for merit, there was 2 opportunities for merit as well. Explain that no children will be born with kidney failure because it was not caused by genetics and only genetic characteristics can be inherited. So see there, won't be passed on and only genetics can be inherited. Your second M explains how will not get kidney failure because caused by the environment or an infection because they only affect somatic or body cells and not gametes, and somatic and body cells cannot be passed on. Lastly, discusses how for an E, you discussed how the characteristics are inherited and the effect of the environment on the acquired characteristics such as kidney failure. Again, a relatively easy E to get. Now, if you put that all together, you can see that you needed 3 A's. And how easy is that to get? Because if you look at it, we've got 1, 2, 3, 4, 5, 6, 7, 8 opportunities. So that's less than 50%. You had 4 A's for an A+, 1 merit out of the 4. Only 1 out of 4, and you get a merit 5. 2 merits out of the 4, you get a merit 6 or a merit plus. Then for E7, you get 2 excellent points with slight mistakes. Okay, so in other words, you get your E, but there were some minor errors. However, number 8 is 2 perfect answers.